Okay, now graphing linear inequalities. So we talked about solving them. Now we're talking about graphing the linear inequality. All right, this is what's new. We graphed linear equations before, but now we're graphing linear inequalities to where there's a little bit of a difference. Okay, first and most important step, make sure your equation is in slope intercept form. And this is just a little reminder, be sure to flip the inequality symbol if you multiply or divide by a negative number. Step 2 is to graph the line. Now the line is either going to be solid or dashed. So you're either going to have a solid line or a dashed line. Now, the way in which that tells you which one I have, in order to have a solid line, I must have less than or equal to or greater than or equal to. Dashed line is either the less than symbol or the greater than symbol. Okay? This goes back to, I think, Unit 1, where I would ask you, is it inclusive or not inclusive? So if I gave you an equation and I said, this symbol, is it inclusive or not inclusive? Not inclusive. Not inclusive meant we had an open what? Circle. We had hole, right? We had a hole in our line, right? Do I have a bunch of holes in between the lines? There you go. So it's the same philosophy. Okay? So it's not inclusive, so I got a bunch of holes. All right? What's your question? Greater than, less than. You read it like a book, left to right. Okay? Once you've figured out what type of line to use, you then need to figure out where you need to shade. Yes, there is shading involved with graphing linear inequalities. Now, you're either going to shade above your line or below your line. Okay? And what tells me to shade above are my greater than symbols. So if I'm given greater than, I will shade above. So if greater than is above, what is below? Less than, or less than or equal to. So let's do some practice. Step 1 is what? Slope-intercept form. I am currently in standard form. I need to be slope-intercept. So, Coach Kimball says, draw your line. Now, to go to slope-intercept form, which is y equals mx plus b, what needs to be by itself? The y does. So I need to take everything that's on the side of the y and move it over. What operations do I do to move something? Adding and subtracting. So I'm going to subtract in this situation. Negative 3y is less than negative 2x plus 15. It's a plus 15 because that's a positive 15 right there. Now I need to isolate my y. How do you isolate something? What operations? Huh? Divide or multiply. Okay? So I am in this situation going to divide. Now I am dividing by a negative. Dun, dun, dun. So what happens to my symbol? It flips. So if I divide by a negative, this goes from less than to greater than. Negative 3 divided by negative 3 equals 1, which is what we want, just 1y. Negative divided by a negative is a positive. 2 divided by 3, is that going to give you a whole number? No, so leave it as a fraction. 2 over 3. Is 2 over 3 in simplest form? Yeah, it can't be reduced anymore. So I have 2 over 3x. Then positive divided by a negative is a negative. 15 divided by 3 is 5. So now I am in y equals mx plus b format, where the number attached to my x is my slope. My constant is my y-intercept. So now I graph it just like I would a linear equation. Start with your y-intercept. Go to -5. Put your dot. -5. Now work your slope. Do I have a positive or negative slope? Positive, because the number's positive. So I'm going to go up 2 over 3. Up 2 over 3. Oh, I'm a little off the graph there. Whoops. Okay. Now before I connect the dots, you must ask yourself 2 questions. Question number 1. Am I inclusive or not inclusive? Not inclusive, which means I'm going to have what type of line? Dashed. So I have a dashed line. Now, this is how I draw my dashed lines. Instead of connecting the dots entirely, I just draw it to halfway. That's how I draw my dashed line. That's my secret. Okay, so now I got a bunch of holes in my line. Okay. Question number 2. Am I shading above the line or below the line? Above. Why am I shading above? Because it's the greater than sign. So I'll take my pen and shade above. How would I do that? You take your pen and you shade above. We do take our test on a computer. Because there's going to be an operation where it says, you'll see it on your Delta Math homework. It'll be like a button, shade top or shade bottom. And it'll just, you click it and it'll shade it. Questions, comments, concerns? Yes, Tim? No, Tim. Yes, Tim, or no, Tim? No. Okay. Before we move on, I do want to talk about a few things. Okay. Up here, we said, are these ordered pairs solutions, yes or no? Okay. So that's if you have the equation and I give you an ordered pair. What if I just give you a graph and I give you a point on the graph? Okay. If I just give you a point on the graph, is this point in the shaded area? So that ordered pair is a solution. If you have an ordered pair in the shaded area, that is a solution. If I gave you this point, is that in the shaded area? No. So it is not a solution. It's not a part of it. Now, what if I gave you this point right here? Is that within the line? Yes. Is this within the line? My slope line. Is that within the slope line? Yeah. Yes. However, what type of line do I have? Dash. I have a dashed line. And dashed line is full of holes. Full of holes. Okay? A dashed line is full of holes. Do we include that, or is that non-inclusive? Not inclusive. Because it's not inclusive, that is not a solution. Even though it is on the line, it's not inclusive because it's a dashed line, because it's full of holes. Got it? Got you good? Sweet. Okay. Turn the page, por favor. Step number 1 when graphing linear inequalities is to make them into what form? Is that already in slope-intercept form? Yes. Yes. So I have my B and I have my M. Okay? My B is where? So I go to -5. Wait, is that 5? 1, 2, 3, 4. Okay? Now, slope is rise over run. So I have my rise of 1 and my run of 3. So I'm going to go up 1 over 3. Up 1 over 3. And then I work in opposites. Do I need to put this many dots? Technically, no. How many dots do you need minimum? 3. Okay. Once I have at least the dots on my graph, okay, I can now ask myself those two very important questions. Question number 1, will I have a dashed line or a solid line? AKA, inclusive or not inclusive? Which means it is non-inclusive. I will have a dashed line, which is not inclusive. And remember, Coach Kimball just says start at one of the dots and draw halfway to the other one, and that will create your dashed line right there. Question number 2, am I shading above or am I shading below? Above. So you take your pen and you go, ah. Yes.
Wait, how do we know if it's a dash?
Inclusive or not inclusive? Is greater than inclusive or not inclusive?
So if it's greater, it's a dash.
No. Greater than. Is it inclusive or not inclusive? Go back to Unit 1. It's not on that paper. Okay, so non-inclusive means I have a hole, right? So like remember when we used to graph it, non-inclusive meant like I have my number line, but there's a hole right there. Remember me talking about that? There's a hole. Okay, same thing. Dash line, I have a hole here. There's a hole, 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 hole. I have spaces. So I like to go back to what I originally taught y'all, inclusive or not inclusive. If it's not inclusive, then my line needs a bunch of holes. So a dash line. If it is inclusive, like if it was this, I would do one solid line because there are no holes. All right. Another way you can think of it is, I think Checkers was saying this, greater than or equal to has a line underneath the inequality, right? So if I have a line under the inequality, my points will be a solid line. If I don't have a line underneath the inequality, then I don't have a solid line. It's another trick. I think that's what Checkers was trying to explain. Okay. Let's look at number 2. Number 2. Okay. Step 1. Make sure we are in slope-intercept form. Are we in slope-intercept form? Yes, we are. So we have a slope and we have a y-intercept. So I can go to my y-intercept and put a point. Now my slope is an integer. It's not a fraction. But I can make it a fraction by putting it over what? 1. Yay. So that means I have a rise of -2, which means I go down. And then I have a run of +1. I like to do multiple dots when I'm doing linear inequalities, just so when I create my line, it's easier. Okay, now, inclusive or not inclusive? Inclusive. There is a line underneath the inequality, which means my dots will make a line. Solid line. Okay? Second question, above or below? Below. Your shading doesn't have to be perfect. I can hear a bunch of people's pencils going shh. Okay? Now, let's say on top of this question, I did that. And I asked you, is that point a solution to the equation? What would you tell me?
No.
Why?
Because
Because it's not in the shaded area. Okay? If I gave you this point, is that a solution?
Yes.
Because it is
In the shaded area.
in the shaded area. If I give you this point, is that a solution?
Yes.
Why?
It's online. No gap.
It's on the line and the line has no gaps. Perfect. Good. Okay? Now, let's do this one here. That'll give us one more practice of converting it to y equals mx plus b. Then we have 2 examples we have to do, and then we will start our homework. Okay? So, first and foremost, we must be in slope-intercept form, which means we need to isolate the y. All that means is get everything away from it. Okay? Then I divide by... Now, I'm dividing by a negative, so my inequality symbol will flip. Okay? Negative divided by a negative is a positive. 5 divided by 2 will give you a decimal. So Coach Kimball has always said, if it gives you a decimal, just leave it as the fraction. And then positive divided by a negative is a negative. 12 divided by 2 is 6. I now have my slope-intercept form, aka slope and y-intercept. I go to -6, which my eyes are going cross-eyed looking at this. There we go. Now I have a positive slope, so I'm going to go up 5 over 2. Up 5 over 2. Okay. Sweet. Ask yourself 2 questions. Question number 1. Dashed or solid? Dashed. Because my inequality is non-inclusive. So I will have a dashed line going up and down. Okay. Question number 2. Above or below? I heard 2 different answers. I still heard 2 different answers. Below, because I have what symbol here? Less than. Less than tells me less than is below. Woo! Questions, comments, concerns, tribulations, or hinklepinks? Any kerfuffles? Conundrums? Quandaries? Questions? All right, let's look at 7 and 8. These are special cases. I have y opposite a constant number. There is no other variable over here, aka there is no slope to look at. I have y opposite of a constant. This goes into what you learned last class, where we had the acronyms VUX and OI. Okay, this is a y equals type sentence, so it is it VUX or OI? It's OI, because the equation I have has a y in it, and OI has a y in it. Okay? Now, what this is telling me is what type of line am I going to have? Vertical or horizontal? Horizontal line. And where is my horizontal line going to be at? -4. So I go to -4. And before I draw the line, though, you must ask yourself one question. Dashed or solid? Solid because... Solid because of the equal to. It has the inequality has a line, so I give this a line. Okay? Then you ask yourself the next question, above or below?
It is below.
Because it is
Less than.
less than. Below because it's less than. Woo! Problem number 8. I have a variable opposite of a constant, so I go to my acronyms of VUX and OI. In this situation, the variable I'm given is an X, so which of the two am I using? Nice. And VUX tells me I have what type of line? A vertical line at X equals 7. So I go all the way to 7. 1, 2, 3, 4, 5, 6, 7. And I draw a vertical line. However, before I draw the line, I have to ask myself 2 questions. Question 1, dashed or solid? Dashed. Right, Tim? Yeah. Question number 2. Above or below?
It is going to
Above. Now, technically, with a vertical line, do I have an above?
No.
No, there is no above. However, I do have a left and right. And if I think about a number line, okay, and I have 0 here, everything to the left gets what? Smaller or bigger?
Bigger.
Everything to the left gets smaller or bigger? Smaller. This is saying everything bigger. So which side do you think I'll shade on?
The left. Yeah. Left. Right.
Literally everything opposite you just said, Kimura. Okay, the right, aka bigger. I've noticed. Okay, now I have 2 more questions to ask y'all. If I asked you, is this point a solution to the equation? What would you tell me? Because it's where? It's in the non-shaded area. If I put a point here and ask you, is that a solution? What would you say?
Yes.
Yes, because it is in the shaded area. If I put a point right here on the line, is that a solution?
No.
Because my line is what? Dashed. There's holes. Wonderful. Great, grand, perfect. We are done